Testing 1, 2, 3. Blah 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 blah. All right, let's let's get this mess started. So, hello again. I think if anyone wanted to ask, well, what's been going on? I missed last week. I know. So about 2 weeks ago, I thought I would be okay. I said, I'm feeling a little sick, but I'm fine, right? And what ended up happening is that I thought that weekend, oh yeah, this is the worst of it. I'm sick, but I'm getting better. Things are improving. It turns out I was horribly mistaken. No, what ended up happening, again, this is a little bit of a silly thing to kind of say. Oh, no, I pressed the wrong button. Oh no. How do I alt tab? Okay. Okay. Anyways, as I was saying, I ended up being sick for like a week and a half. I wasn't even in the beginning stages. I was like barely in the throes of it, and then it got much worse. So yeah, I missed last week's session because even though I was being bold and saying, oh yeah, nah, I'd tutor even when I'm ill. No, when I'm actually really ill, I would just lay in bed and kind of. So there's that. Just a bit of a random thing to say. Time while I'm trying to get things set up. All right, there we go. Yeah, that happens. That's part of life. Okay. Oh. So right now I'm just trying to get this prepared, put my face on, as it were. I'm getting good at that. I'm getting good at doing this quickly. Let's see. Let's just do it like that. There we go. Okay, does my mute button work? Oh. Well, that's a mistake. I was supposed to do what is it? There we go. All right. Now I'm finally all set up. Okay. So, last time I was able to get things ready with a actual tutoring, right? Actual math. That was pretty cool. I think that was, what was it? Algebra and trigonometry? Yeah, it was just some kind of basic stuff. Now again, I'm gonna kind of hop around and see what I can do next. Oh boy. Do I want to do simplifying exponents and order of operations? I don't know. That's the funny thing, right? Again, how helpful is talking about random things in math if no one's here to look at it? If anything, I'd rather talk about something more real-world applications of math and how that kind of thing works. Pythagorean theorem? I'm not sure. Let's see. Denominator. Simplifying rational exponents. Is anyone doing that? Is that a thing? Do people go like, oh yeah, rational exponents. I simplify those all the time. In fact, that's kind of my job. I don't know. Polynomials. Oh, ooh, that sounds fun. Okay, let me Oh boy. Okay. Polynomials. I'm trying to remember how to screenshot again, because again, I have some weird software. Oh no no no! Oh no, I missed it. Okay okay, I'm back. Here we go. I think I gotta. There we go. All right. So the weird thing is that you can actually copy paste. This is actually conferencing software. So if anyone needs help with tutoring, what we can do is you could copy something from a PDF, textbook, website, whatever, and then go on to here. Sorry for the flickering. Oh, please. Ah, there it is. Oh wait, my face is in the way. Well, let's move it over here. All right. So people can copy and paste and put down homework stuff, and we can kind of go over it. I think about 2 weeks ago we did something from the same textbook, right? But a bit further back. Oh, can I copy more? Ooh. Hold on, how much can I guess I could just get like another chunk of a page, right? Yeah, let's give it a shot. Alright. Will it overwrite it though? I don't know. Let's see. But let's get like a nice big chunk and try to put it here. Okay. Hey, here's the next page. Alright, a little small, but it works. Alright. And again, you know, for anyone that's just coming by, probably saw the message that I posted. If you actually need tutoring with homework that you're doing right now, ideally math, but I can also help with like English and other stuff. Just, man, derivatives is so hard. Statistics is hard. But hey, if you need it, you got it. But, you know, come in here, it's totally free, but you get what you pay for. Which is, yeah. Alright. Let's see. Now what I'm going to do is I'm definitely not alt-tabbed and checking something to make sure that the stream is working. Well, I'm already like, what, 8 minutes in? Yeah, that's fine. Yeah, we're fine. Okay, here we go. Polynomials. So, this could be something... Now again, when it comes to tutoring, it's a bit different from teaching, right? Tutoring is more like helping someone explain, conceptualize, really kind of grasp the material. Whereas teachers, they just kind of post it on a wall and they just say, you know, hey, this is today's lesson, it's blah 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 blah, and you're gonna do this equation right here, and you're gonna copy and paste it and do it like 10 times for all these other equations that's in your book. Oh wait, my head's covering it. Let me do my join off to the side. There we go. Alright. So it's kind of like, here's the class, here's a lesson, here's the equation, here's the book. Put the equation in the book, problems, a bunch of times, turn it in, that's your homework, right? Now it could also be on a laptop or computer. Just say, hey, here's the equation, on the teacher's screen. Let's see, is that like a recording live button? Yeah, it looks like it. And then here's your school laptop with buttons. And then you just basically put their equation into the homework and then you submit it. Maybe multiple choice, maybe hand drawn. I don't know. There's a whole bunch of different ways out there. Right? Maybe, yeah, hopefully, right? Hopefully you're not using online tools and just copy pasting. But I mean, you know, to each their own. And in that, I mean, if you're double checking your work after you try to solve it on your own, cool. Yeah, that's totally fine. But if you're trying to just use some program to solve the homework for you. Well, it's going to cause a bit of a problem when you try to do like a test, or if they try to do like a blue book test, or if you try to do the SATs, or if you're working at a job that requires... Oh, my apologies if that came through. If you're doing a job that, where you're trying to do math equations, and they're trying to test you in like an enclosed room with no internet, you know? Yeah, that's... you're just kind of making things a bit hard for yourself in that end. Anyways, enough rambling. Point is that that is what school and teaching is, right? Tutoring's a bit different where, you know, they kind of do this thing, and you look at it and you're like, I can't make heads or tails of it. This is weird. Why do I need to know this? What's this for? How can I understand this? The teacher just barely went over it, right? Or I have a substitute and they didn't really explain anything. And so it's to kind of clear the fog and to explain, well, you know, this is the, you know, practical use case of this. This is, you know, how you can learn this thing. This is how it applies to other future tests that you may take, and how it can help you in whatever career you're on, right? Although, by far, a lot of math stuff, it seems crazy, but it really just kind of applies to personal finance, right? Like money is a number, income's a number, bills are numbers, expenses are numbers, so trying to balance the books and work out those numbers, that's really where a lot of math stuff comes in. So, why am I erasing? I don't have to erase. I like my little doodles. Oh man. Can I control Z enough? Yeah, okay, that's good enough. Cool. But, you know, until someone actually comes in and has something that they want to cover, you know, I'll just go over polynomials. By the way, once again, conferencing software, it's pretty neat. There's a call system. You could join if you want a voice chat. For homework reasons. You can doodle on this with me, so it's not just you staring at a screen the whole time and just like, okay, yeah, homework, great. It's a weekday and I just got done doing homework and now I gotta do more homework. Ooh. No. It's more like, yeah, we'll just use your examples. You could copy paste it onto here and go over it together. So, I think it's pretty neat. Alright, but going over this. For now, right? If anyone wants to interject or bring their own stuff to the table, down for that. But until then, let's just fill the space with something that might be helpful. Polynomials. Alright, now I'm finally getting into it. After so long. Now, I remember someone talking about this, that they had this near the end of their last semester. And they were struggling with it a bit. I think, right? They kind of gave a vague description about like shapes and different kinds of shapes and areas and whatnot. So, you know, hopefully if they come around again, they can find this. And if not today, then hey, there's always the archive on YouTube, right? Let's see. Degree, coefficient, polynomial. Okay, whatever. I just like saying the word polynomials. What's the real thing? Foil. First, outer, inner, last? Okay. Add, subtract, multiply, blah, blah, blah. Whatever. Alright, story time. Little library. Front shape, square, triangle, rectangular door. Area of the library is to purchase correct amount of paint. Well, this is a nice... I think this is a really lovely attempt. Kind of like the, you know, old math homeworks where it's just like, oh yeah, you have so many apples, and this other person has so many apples, and then if you eat this or share this much, you know how many apples are left over for dinner, right? That kind of thing. So this is someone trying to find the area to paint a small book shape, a small house shape. Now the key thing here, in real life terms, is house and paint. Because, yeah, if you're painting a room, if you're painting a house, yeah, you kind of want to have a good ballpark of the measurement. I mean, you could just bust out like a ruler and, you know, figure out how much paint you'll need. You can also, if you have a friend or family member who does painting, you can kind of ask them, you know, how much paint do you think I need? You know, you don't want to get any of those, like, miniature little paints and kind of go at it with a tiny brush. Yeah, you kind of want those big honking things and a tray and a roller, and you just kind of go at it, make sure you have painter's tape, the whole shebang. So this is, I guess, a nice attempt at that, but it's using smaller numbers, right? Maybe less practical numbers, but smaller numbers that we can kind of use as a formula, and you can kind of figure things out. Now also, here's the thing. They're not covering that you might need multiple layers of paint, right? It's not just you slap it on and it's done. It's not like wallpaper. Paint is something you kind of have to layer on maybe a couple times. Maybe if you got some bubbles, you gotta sand it out, and so forth. Yeah, then also talking about, like, you know, plastic you need to get to put on, like, to the floors. Painter's tape around the electrical parts. But yeah, oh well. This I guess is a simple example. Okay. But yes, you may have to use these kinds of equations, maybe, if you're actually painting a location. That could be yours, a friend's, someone who's paying you to do it. So this could be very helpful, right? In fact, not only that, you could use it as, okay. I was going to say you can also use general algebra formulas to kind of calculate, you know, cost to, how should I do it? I should be doodling when I do this. You could probably use a formula to calculate costs to paint ratio, or, you know, supply ratio, right? Where you have maybe some supplies, like paint, and then here's the money that you get. Why did I do that like that? Here's the money that you get to get paid for the job. And then you also got to subtract maybe gas to travel there. Which would be dollars of gas plus distance. No, times distance. Okay, well, there's an actual formula for this. But generally, if you want to kind of outline it, you would have the cost in which you get paid to do a job to paint a location, minus the cost of supplies to do it, minus the cost of gas, right? Minus the cost of maybe extra hands, hired help. And not only would you consider these costs as someone who might want to get paid to paint, right? You could flip it, and maybe you have your own place that you want to get painted, right? So if you front the cost of supplies, maybe you just need to hire the extra hands, and then those people will help you out do the job. And then this amount of money that you have to pay for the thing could be, you know, cut in half accordingly, and just go to that, and then you get all this in savings. Well, not really savings. It kind of goes to supplies, but you're not paying extra on top of the supplies. Sorry if it's a little disjointed, but if you've ever had to paint a place, I feel like you kind of know what I'm talking about. Alright, but going back to our simple example, right? We have the measurements of the front house, blah blah blah. Good enough. Alright, find the first A of the square in feet. Now, I know I had this up this whole time, but I'm going to try not to look at it. So let's see, what is the area of this thing? Well, it looks like x is here. And if that's 2x and this is 2x. And the reason why we can kind of put these numbers willy-nilly, because it's not really willy-nilly. For one side, you know, they have it clearly labeled what is 1 foot, right? And because these are squares, or rectangles, or these are, how do I put it? These are shapes that have 90-degree angles. And so because they have a 90-degree angle on them, all the way around, then that must mean that the other side is even. Now, there can be cases where, let's say, for example, we get something that's like eraser shaped, right? Where this isn't quite a 90-degree angle, but because it's a parallelogram, you know, this distance, let's call it smiley face, could equal this distance, and this distance equals this distance. Because if you line them up, they're kind of the same, right? Now again, we're doing an assumption here. If you actually have like a piece of wood or a house, you know, you're gonna have those little weird oblong bits. You know, there might be something like, oh, what is it? Like a dryer ventilation right there. There might be a window, right? And usually in these things, actually, I think I know what they're talking about. It's those little houses that look like bird houses where people throw books in them. This whole front part is actually a window, right? It actually doesn't look anything like this. They kind of look like this, where this is, let's see, what's a Minecraft window texture look like? Glass, something like this, right? And then this is actually the wood thing, and then this is kind of like a door, and then here's the little fake house thing. Good enough. Oh, my face might be in the way. Whoopsie daisy, sorry. Alright, and so the actual area of the paint that you would need to paint is maybe, you know, oh wait, I'm missing the hinges. There it is. So the actual area of the paint you might need to paint is right here. Maybe a little bit on the door, but you want to have the glass window so that people actually kind of see what books are inside and how many there are without even having to open it, so they can just kind of eyeball it, right? Otherwise you have people like looking and peering all the time. But I mean, it's the same principle why there's like, whatchamacallit? Newspaper dispensary thingies. The things that have newspapers that have the glass in front, right? So people can see. They might want to have to paint here, and then of course there's paint on all the other sides behind it, and then maybe even below it a little bit if you want. Yeah. So this is actually a terrible example of this little thing that they're talking about, the little book thing. Because how are you supposed to fit a book? Well, I didn't read the actual thing. Let's see. Rectangular door through which people can take and donate books. Yeah, all right. So imagine this. Again, I'm getting a little lost in the weeds, but that's the kind of funny thing about these math examples, right? I don't have to do them. I can have fun just critiquing them. But I'll get to it. I will. I promise. If it's your actual homework, oh, for sure. Yeah, we'll get to it. I won't, you know, make fun of it too much. But let's say, for example, there's this big box with a tiny hole, right? And then you got a small pocket book like this. You got a big book like this. And how are you supposed to, like, you know, stick your hand in there? Just trying to reach for these big giant books. Wait a minute. Let me do it like this. Ah, that's much better. Alright. So you put your hand in there. Alright, maybe you can get the little one. But then if you have a big book, you can't really get it in there. You can't really get it out, unless maybe you pop it open from the top. But then again, that kind of defeats the purpose. I don't know. It's very silly. If anyone is in the business of making small books, in the business of making these things, yeah, don't build it like a birdhouse. Build it like a cabinet or a newspaper dispensary thing. Alright, anyways. So we're finding the area of the first square in square feet. Now I'm gonna cover, hopefully my face is covering this thing. Oh, yeah? Yeah? Is my body covering it? Alright, cool. I mean, yes, I can see it, but I'm not gonna look at the answer right here. But hopefully for the audience, this will be a bit of a mystery. Alright. So, again, because these things are 90-degree angles, we can kind of assume that one side equals the other side. And so if this side is x right here, then we can safely assume that this side is x. Oh, this is 1 foot, not 1 f. Not if. Alright, so then we're gonna put this up here. And yeah, this is 1 foot. Let's just bring the 1 foot there. This is 2x, we're bringing the 2x there. And we're trying to find what? The area of the square. Alright. So, as a formula then, it's kind of nice and easy, right? If you think of, I don't know, like an array, I guess? Where you have something like this. You have 2 times 2, and that equals 4, right? There's 4 squares. So that works out, right? Because you have 1, 2, 3, 4. I know, probably basic stuff. If someone's eyeballing this, they might already know. But that makes it easy because you could just plug it in with any variable, right? So in here we have 2x as one side. So I'm going to put 2x here. By how much? Now this bottom one is not listed. But we do have some ideas, right? We have this line right here, which is 1 foot. So we have 1 foot plus, I guess we could say y. Wait a minute, is it a perfect square? Because if it's a perfect square, then we could just probably multiply it by itself, right? Okay. Hold on. I have to. I actually have to read. Let's see. The library. Shape a square. Shaped with a square, topped with a triangle. Okay, so if it's a square and not a, I don't know, other kind of shape, then yeah, that's nice and easy. So the easy answer would actually be, assuming that this is a perfect square, you just multiply it all around the sides. So it'd just be 2x times 2x. Right? And another way we could do that is, there's a few ways, right? You could have 2x times 2x, but because we're actually doing variable math, they don't like to do the they don't like to do the times symbol like that. They like to do dots. You could put it together like these in parentheses. And it looks like you can even, spoiler alert, might have already seen it, just square it. So 2x squared is 4x squared. It's right there. Cool. But I wonder if there's a way you could solve it just in case it wasn't like a perfect square. You know, what if it was off by an inch? So let me see if I could figure that out. I could be wrong, right? Could be horribly wrong here. But let me just try something. Alright, here we go. So we got 2x for one side. We have the other side is at least 1 foot. Maybe plus y, where y is the distance that is not defined here. Okay, alright. But we have another number we can work with. And that is x. Okay, so then we have the x that's right here. So the area of the square within the square is x on one side and 1 foot on the other side. So that's one. That's okay. That's kind of like a phantom one. X feet. Whoops, that's not a T. Does that help? Not really. I think this number might actually help more. But then again, that has to assume that this is actually a perfect right triangle, if it is. Because if we assume that this is a perfect right triangle with the 3/2 feet as the length of this line on the middle, yeah, I don't know. I think unless they told us that this was actually a perfect square, I don't know if we actually have enough information to solve this otherwise. And that's kind of the tricky thing, right? Because when it comes to the harder math stuff, sometimes they'll throw you in for a loop, and they might, you know, make it really easy, or look easy, but actually make it really hard. Or, on the flip side, right, maybe they'll, I shouldn't say they, certain textbooks that you might use that are maybe older or incorrect, they might have like a not perfectly to scale, but then they'll say, yeah, it's a square. Sorry for a bad drawing. And then you're like, oh my goodness, I was worried about this thing for nothing. Alright. I'm gonna try not to overthink it. Gonna keep it nice and simple. They have it nice and simple. Let's work with this. That's kind of the thing, right? When it comes to math, homework and tests especially, it's really easy to overthink it, when really sometimes just good old guesstimations and brute force might actually work. So, let's try to guesstimate brute force the next one. Find the area of the triangle in square feet. Alright, well that should be easy. Assuming it's a square, then that means that this area is also 2x. So then you cut it in half, then you just have x for this side. And you have 3/2. Yeah, plug in, what is it, good old Pythagorean theorem? No, wait, no you don't. You just multiply the sides, divide it by 2. That's what it is. Alright. So then you have 3/2 times x, which would be 3x/2. But then also you divide the whole thing by 2. That's an ugly way to draw it. I should have done it better. I should have said it's multiplied by 1/2. There it is. And then 1 times 3x equals 3x, and 2 times 2 equals 4. So the area of the triangle should... what? Oh. Oh, I was doing just this triangle. That was my mistake. I was doing just this triangle. They meant the whole triangle. Oh. My bad. Hey, that was an honest mistake, right? Because, again, I didn't read the whole thing. Because when they made the triangle on top, they actually meant just this giant thing as a triangle. This divider isn't saying that they're two separate triangles and here's one and here's the other. It's just kind of a marker showing that this is the half point of this triangle and the other half is there. So it actually wouldn't be divided by half. It would just be the whole thing. If you're finding the area of a square, you're trying to cut it in half to be a triangle, you just divide it by half, easy. But that's not the case because there are two halves. And so because there are two halves, you kind of divide it by half to find this area. But then you also multiply by 2 because there's two sides of it. Okay. Right, and then they even have a nice formula, right? 1/2 times base times height. That would have been easy too. And again, there you could kind of see that it is the half, because it's half of a full square, right? And the base, the full base is 2x, but I already cut that in half. And then you just have 3/2, so it's just 3/2. Yeah. Oh, well there you go. Alright, no spoilers. Next, find the area of the rectangular door in square feet. Okay, I'm not gonna mess this up, I swear. Alright, so the area of this thing is you just do x times 1 foot. So it would be x feet. Is that right? Okay, so yes, it is X. But I think a lot of this stuff should be in... Wait, is it 1 foot? Wait. Oh my goodness. This is in feet. This whole thing's in feet. Whoa, that's huge. Hold on. This thing's like a giant box. Where like the door is like a whole foot. At least in width. Okay. Wow. Yeah, this isn't like a tiny little thing. Yeah, if anything, it might be like, I don't know, maybe if drawn to scale, it might look like this. Right? If it's gonna be that big? Like a whole foot? See, that makes more sense. Okay. Yeah, wow, this is in feet. Okay. Sure. Alright, the area of the front of the library can be subtracting the area of the rectangle. Now, although I'm kind of brushing this off, this is a kind of a formula where they get all the numbers, kind of added, put it together as like squared feet, right? And this is kind of what they might want as the end result, wherein you find out, okay, if how much paint you need, well, you get the answer from the first one, which is the box, you minus this little door, you add the roof, and then it's simplified into this. Okay. Well, that's kind of okay. That's kind of okay. The reason why I say it's kind of okay is because it actually does apply different formulas for area, right? Because you got the square formula, which is if a thing's a perfect square, you have it squared, and that is a nice shortcut to find the area of a square. You have the triangle formula to find the area of a triangle, and that is a nice easy way to kind of do this. And then you have the area of any kind of, I don't know, rectangle or parallelogram, right? It's just length times width. And so it applies all these together to be able to find the area of this simple shape. And so I think I wasn't giving this equation and what they're trying to teach here enough credit. It is actually a very clever and good way to kind of go about this. So whoever made this, hey, good for you. I'm sorry for ragging on you about the house thing. That was maybe a bit uncalled for and not worth the time. When really, it putting it together as a more complex formula actually worked out pretty well. Especially since you don't have everything as a variable squared. Because here you actually have different parts where, you know, here's the, whatchamacallit? The area for the square itself actually has x squared, and it doesn't truly add neatly into x, because x and x squared are two different sets of numbers, so they do have to be separated like this. So yeah, this is a pretty good one. Yeah, I think my only and here's another clever thing, right? So they only have the measurements in feet for the triangle and for the door, right? They don't actually have this part in feet. It's just straight 2x. So the interesting thing is that this could be measured in maybe inches, this could be maybe in feet. We don't actually know, which is why they only have the feet squared right here with the variable just as x instead of right here, because this could be like a totally different number, right? It's not exactly feet. And to kind of show that, what if we, oh no, I don't think there's an example of where it can outsize it. Let's assume x is 1, right? so assuming x is 1, then x squared would be 1 times 4 plus 1/2 times 1 feet squared. So you have 4 plus 1 feet squared over 2. But would this still be in feet? I don't know. I don't know, because they didn't, again, they didn't give us a number. Because here we actually have the measurement in feet squared. But here it's just kind of like a, I don't know, whatever. Because we can't exactly plug in feet. Because if x equals 1 foot, right, then technically it would be 1/2 times 1 foot times feet squared, right? But on one side, plus 4 1 foot squared. So here you could get 4 feet squared, right? As the area. But then, I think, if I'm correct, the feet would actually multiply into this feet. So you actually have 1 feet cubed over 2. You still kind of have into this area where they don't quite line up. So the fact that they have just this thing as a number on this side, without any kind of distance, I think, I don't know. It feels like my gut tells me it's an error. But maybe again, I could just be looking into it more than I should. I just gave this thing a lot of compliments because it is a very good equation. But now that I'm looking at it again, I don't know. They really should have accounted for some kind of feet measurement. And it could have been solved easily if they had this just as 2, you know, x feet, or 2 feet x, whatever, either one. But they didn't. And so that's mildly concerning. Okay, well, moving on. Alright, so, degree and leading coefficient of polynomials. Right. So, technically the term doesn't mean just this thing as a shape, I guess. It means this thing as a formula with different degrees. Okay. Sorry if I'm covering it with my big head. Okay, a monomial is where there's only one number. Okay, so 5x to the 4th power. And if they have one variable and non-variable, that's a binomial. So if there's like a squared or whatever, then it's a polynomial. That makes sense. Alright, now why would anyone need to know this kind of stuff? Maybe you might not need to know the specific terms, but it is helpful when trying to calculate something that has more than one variable. I know that seems... Well, okay, more than one variable to 1 power. And again, I know restating basically what they're saying doesn't really make a lot of sense, and really clarifying it, so let me just try again. Let's see. How could this be applied? Could it be applied in distance? I think they tried it in areas, which could work. Well, this is a tricky one, because I know that this is an important math formula, and that knowing this sort of thing, and knowing that they don't combine, and making sure that they stay separate, is a very important math concept in higher levels of calculus. Or maybe you have something to, I don't know, let's say x to the 4th power plus 9 over x squared plus x to the I mean, okay, I think you can actually kind of break this down a little bit. You can, right? But let's say, for example, it's a square root. There you go. That makes it nice and annoying. And then I don't know, plus x cubed? Sure, why not, right? Is there a practical use for these needlessly complicated equations? I think so, and I think it all... Unfortunately, I think it all eventually leads to derivatives. Derivatives, no. But yes. So the reason why they bring up this kind of math formula and they teach you and they don't just stop at regular algebra that you can kind of use in a practical sense is because you kind of need these complex dimensions to figure out things like derivatives, areas of 3D shapes, areas of all kinds of complex things, volume. It's not a good time. So I'll put it this way. If this is the highest level math you can go, hey, thank your lucky stars, right? But it can get higher, and it uses some of this stuff. Use some of these principles. Alright. I'm gonna leave that there. Because I have a feeling I know where this is going. And let me just see if I could find the next step that way I can kind of go to. Let's see. Multiplying polynomials. Yep. Several variables. Sure, why not? Let's just jump way ahead. Alright, so here's some of the madness to come, right? Let's copy this. Let me find a nice spot. Boom. Is it gonna be big? Oh no, it's gonna be small. Well, that's nice. Alright. Performing operations with polynomials of several variables. Oh boy. Now, I think I talked about this in a previous example where there's like, you know, smiley face times frowny face, whatever. But of course, they don't like to do that. They like to do more easy to type things like A's and B's and X's and Y's. So, oh geez, it already has the answer there though. Is there a way I could just... Alright, you know what, let me just break it down. So, now when you're looking at this means that there's multiple things you have to... I don't know. This wouldn't be used... Would this be used in... Yeah, this would be used in chemistry maybe. So I'm just trying to think of how can this be practically applied. And the only way I could think of it is once again with money. Right? How would it work with money? I don't know. Maybe you're trying to figure out if these people owe you money and you owe this person money, and you're trying to write a formula to kind of simplify it to where you can say, okay, so this is the consistent formula I have for bills, where if I have a certain amount of money and if this person gives me a certain amount of money, then I can plug it in to see if I can, you know, have it all zero out, or at least, you know, go in the positives a little bit. But again, I don't know. Just eyeballing it, it's a little tricky. Okay. But I guess just to kind of draw this thing out, what they would want you to do is to kind of share the love and spread this out, and that's called the distributive property, which I think I covered a bit before. And it looks like this. Again, this would be a lot easier if it was someone else's homework, in that they wouldn't have the answers kind of out here. And it's kind of tempting, I'll say this. If you have homework that kind of has the answers like this, it's easy to have to just eyeball it, say, okay, that kind of makes sense, and has one ear go out the other, right? So, well, what's a better way to put this whole thing? If A was, I don't know. Not apples. Bear with me a minute while I try to figure this out. Slices? A charcuterie board. Okay. Alright, let's try that then. A is apples. B is bougie cheese. Let's go with C with cheese. And then let's go with B is berries, right? Alright. Let's overcomplicate something very simple. Say, for example, you want to make a charcuterie board, a snack board for a bunch of people that are coming over, right? You got apples, you got berries, you got cheese. And you're trying to figure out what is the perfect ratio that you need to spread these things out. How do you dice and slice these things up? How many chunks do you need to make this the most mathematically correct and most appealing looking charcuterie board you can possibly have? Right? Okay. You got a big apple. You got 2 big berries, right? And then you think, okay, well, I want to make the apple into maybe 4 times the amount that I have of the berries and the cheese. And I know that people are going to eat the berries first, so that's a minus. I know people are going to eat the cheese first, that's a minus. But then also the berries are twice the size, and maybe the apples or something. I don't know, right? But let's say, for example, if your mind works this way, where you cannot fathom just cutting these apples and berries and cheeses into cubes and say good enough. You have to have a formula with which you need to figure out what is the exact perfect ratio to make everyone happy. If you have that mindset, then this is the formula for you. Polynomials. This is how you do it, alright? So you face off with this first funky equation, which is incomplete, and you think, alright, well, I need to have this apple to berry ratio, where I have twice as many berries as I have apples, right? But I also need to multiply it so then, you know, these apples that are 4 times the size of the berries and cheeses, and then I need to actually stuff these things in there, right? Maybe it's a berry stuffed apples, or cheese stuffed apples, right? Like an olive. I don't know. We'll just go with that. So, then the first thing you're going to do is you're going to do the distributive property. You're going to look at the apples and you think, okay, well now I got to have the apples properly ratioed to the berries and cheeses. And I need to have the berries, oops, not that way. And I need to have the berries perfectly ratioed to the apples, berries, and cheeses, because I have twice as much, right? And I'm going to mash the whole thing. I'm going to combine it all. Then, once you distribute it and get to this equation, then you think, okay, now I need to figure out the apples' exact ratios to the berries and cheeses, and I need to find the berries' exact ratio to the berries and cheeses and apples. Alright, so then you distribute it again. And so now you have a squares, you have a and b, a and c, a, b, b squared, b, c. And you're like, okay, now I can kind of have this equation, but it's all kind of spread out and funky. Is there anything I can actually combine? Well, yes, there is. Because you have AB right here, which is the apple to berry ratio on that end, and another apple to berry ratio here, with also the positive in the middle. Can't forget that. So, then you want to combine those two and kind of squish it to make it a little bit cleaner of a formula. And once you do that, it kind of looks like this. You minus 7 to the 1, and then finally you have, okay, so now I'm going to have apples squared with the 7 apples and berries, right? But you're going to have that much less, at least one less, cheese stuffed apples, and then you're going to have twice as less cheese stuffed berries, and then you're going to even have twice as less berries squared. So even though you have a lot of berries, you're actually going to have a lot less because they're going to be divvied up into these other parts. And you're going to have less cheese, so you're actually going to end up with a ton of apples. Just a ton of apple pieces. And that's why you're stuffing all these things into apples, because you have way too many apples. And this is the formula you're going to use to perfectly ratio out your foods in this mathematically correct charcuterie board. Wow, what a silly example. But hey, if it works, right? If this helps you kind of understand, and well, maybe it doesn't really help you visualize it. Because like, what would berries squared be? You know what? If a BC is a cheese stuffed berry, then this B squared is a berry stuffed berry, which means that it is technically a whole berry. And then here you have cheese stuffed berries. And then here you have cheese stuffed apples. And then here you'd have, what? Berries. Oh, no, wait, I'm getting these backwards. No, cheese stuffed berries. So this is the berries are stuffed. So this is berry stuffed apples. And then here you have whole apples, right? And then here you can actually plug in the amount of cheese, berries, and apples that you have to figure out exactly how you need to build this thing. So say, for example, if you have no cheese, no berries, no apples. What do you have? You have nothing. You have 0. There you go. Congratulations. Everyone's hungry, and you got nothing to show for it, except this cool formula. But let's say, for example, it's not 0, right? Let's say you have at least one of each, okay? Or you have a ratio of 1 each, okay? Oh, no. Actually, these are the ratios, though, aren't they? Because then for every 4 apples, you would need to have 7 berry stuffed apples. And then you would expect people to eat cheese stuffed berries. 2 cheese stuffed berries. And a whole berry. 2 whole berries. Well, then again, you also have to quantify what is the pluses and minuses, right? Is the plus things that you're bringing to the board, and minuses the things that you've run out of or spoiled? Or is the plus things that people are putting on the board, and minuses the things that they're eating off the board? That's a tricky question. Because in this insane example, right, this formula could apply either to the dynamic with which how these berries, cheeses, and apples are consumed on the board itself, or they need to apply on you preparing the board. So I've incorrectly mixed those two. My apologies. Instead, let's just say that this is an example of preparing the board itself, right? So for every berry that you buy, you need to expect at least 2 whole berries to have soured. For every cheese stuffed berry, you should expect every 2 to have fumbled and to gone all squishy and rogue and not worked out. So you need to buy a surplus because you're going to expect these things to go bad. And then for every cheese stuffed berry or apple, you would expect at least one of them to be botched, right? But for somehow, the berry stuffed apples, for every one you do, because the berries are so small, you can actually fit 7 into them and maybe even subdivide it into 7 because they just mush so perfectly. And then for every whole apple, you should expect, well, you almost have 4 times the apples, because if you cut an apple into 4 slices, you could count it as 4 whole apples, even though they're technically not whole apples. These are whole apple chunks that are just apple themselves, without any extras to it. Now that makes sense. Now that makes sense as a way for someone to think of math in terms of very simple food presentation. Yeah, there you go. Alright, and that was my this week's lesson in polynomials in a very silly and almost deranged way. But you know what? If it helps someone to understand why these things exist and why they might be important, I hope it helps, right? And once again, if anyone needs help, they can either... Again, I know this is a very restricted time frame, so if anyone wants tutoring, you can always please send me a message on Twitter. No, not Twitter. I don't have a Twitter. Twitch. You can send me a message on Twitch, a DM. You could also send me a message on Instagram. And we could set up a time frame in which I could help you on the weekends, right? Anytime during the weekend, basically. Well, not this weekend, but next weekend. I'll be able to help you out. Yeah. Free tutoring. Again, you get what you pay for, but I hope I'm able to help out. Yeah. Alright, until then, it's 8 o'clock, so I'm out for the night, and I hope everyone has a good one. See y'all next week.